I'm Chemistry, welcome to ReactionWatch. Today we'll be looking at what factors affect the rate of a chemical reaction. But Kim, you're probably asking me, what exactly is a chemical reaction? A chemical reaction is the process of forming a new substance through the rearrangement of molecules or ions. Reactions happen based on what's known as the collision theory. This theory states that in order for a reaction to occur, molecules must collide at the proper orientation with enough energy. The energy required is known as the activation energy and can be shown in this graph. It differs depending on exactly what is reacting. Collisions must occur with at least this much energy in order to break intermolecular bonds and allow new bonds to be formed. Molecules also have to collide with the right parts of each molecule oriented towards each other, otherwise they just bounce away. Because both of these requirements must be met, the probability of a collision resulting in a reaction is very small. Some elements are simply more reactive. Alkali metals react readily in water, whereas the noble gases very rarely react at all. Increasing reaction rate is all about increasing the number of collisions that successfully result in a reaction. But what external factors affect reaction rate? Luckily today we have a team of experts in. We cross now to our first correspondent. Over to you, Connor.
Thanks, Kim. Concentration is a key factor in affecting reaction rate. We took an equivalent molar value of hydrochloric acid at 3 different concentrations and reacted them with strips of magnesium. The highest concentration of hydrochloric acid reacted with magnesium the quickest, even though it had the exact same molar value as the other two. And this is why. When the magnesium was dropped into a low concentration solution, not as many collisions were happening. Let's say there were 10 collisions happening per second, and 1 in 10 collisions was a successful reaction. That gives a fairly small reaction rate. Now increase the concentration. There's the same amount of substance, but molecules have a smaller area in which to move about, and this means the collisions must happen more frequently. Still only 1 in 10 collisions are successful, but now there are 50 collisions happening per second, and so 5 of these will be successful, thus increasing the overall reaction rate. Back to you, Kim.
Thanks for that, Connor. We now cross to our expert on heat energy, Tim Pritchard.
Thanks, Kim. Hi, everyone. Changing the temperature of a reaction significantly affects the reaction rate. If you think back to the collision theory Kim mentioned earlier, she spoke of an activation energy. Heating a reaction adds energy to the particles, and thus there are proportionally more particles colliding with enough energy to reach activation point. We decided to test this out in the lab and conducted an experiment involving the acidification of sodium thiosulfate. This reaction produces a fine precipitate, which turned the solution opaque. Placing a test tube over a smiley face, we measured the amount of time it took for the smiley face to disappear completely at different temperatures, thus indicating the rate of reaction. This was our graph of results, and as you can see, as the temperature increased, the less time it took for the reaction to occur. This confirmed what we knew already about heat energy, activation energy, and the collision theory.
Thanks, Tim. We now head to Bondi Beach, where our next correspondent, Sarah, is waiting for us.
Hi, I'm Surfer Sarah, and I've taken a day off from the beach to come and tell you about the connections we found between surface area and reaction rate, and I'll tell you now, it makes a lot of sense. We took some marble chips made of calcium carbonate. Half of them we grinded up into a very fine powder, and the other half we left as chips. We then reacted these with hydrochloric acid, and the gas formed filled up balloons on the top. These balloons were a great indicator of reaction rate, and we could easily see which one was reacting faster. It was the powder. When a solid substance has a low surface area, the outside is the only part that is able to collide with another substance, thus meaning that less collisions are happening. When you break down the substance and increase the surface area, more collisions are happening, and more collisions means a greater reaction rate. Sick! It's like when you're catching waves. You don't often collide with enough energy or the right orientation, but when you do, there's certainly a reaction. I once broke a nose. Back to you, Kim.
Thanks, Sarah. We now cross to Kat, our final correspondent for today.
Hi everyone. Catalysts are substances that change the rate of reaction. How do catalysts work? No one knows, except science does. Catalyst provides an alternative pathway with a different activation energy. If the activation energy is lower, then more of the collisions occurring will happen with enough energy to react. We tested this in the lab. We set up 2 experiments of zinc dissolving in hydrochloric acid. Both had the same amount of acid and zinc, but one had copper 2 sulfate added. The copper 2 sulfate acted as a catalyst, and thus that reaction had a faster reaction rate. Well done, catalyst. Back to you, Kim.
Thanks, Kat. We know you love alternative pathways. So that's it, folks. Factors that affect reaction rate. Please join us next week for Equilibrium with my good friend KC. I've been Chemistry for ReactionWatch.